Before we get to page 10, I did want to just put some little notes here about 3 and 4. So this is what we're doing here when we're changing the denominator. That is called conditional probability. Probability. Sure. Conditional probability. And we're focusing in on a subset. We're not talking about the whole group. So if you notice in the first question, we were taking everything out of 30, and then we change it to specifically a group of people of that 30. So really, we're changing the denominator there. And when you see that word given, that's going to be the little signal to you to like, hey, I got to really focus on what specific group am I looking at? And you're looking at, in this case, the people who can do evil eyebrow versus people who can't do evil eyebrow in 3 and 4. All right, continuing on to a set of data for all seniors at wherever WHS is. Never heard of it. And we're going to find each of the following in the table below for all the seniors there. So number 6A, we want yes, taco tongue. So that's out of everyone, people who can do taco tongue. It looks like there's 480 seniors out of 600. When we divide that, it gives us 0.8 or about 80%. And then part B says yes, taco tongue, given we're focusing just on people who can do evil eyebrow. So the people who can do evil eyebrow, there's just that 200 now. And the ones that can do taco tongue are that 180. So we can say that's 180 out of 200. And when we do 180 divided by 200, that gives us 0.9 or 90%. Part C says, yes, taco tongue, given no evil eyebrow. So now we're focusing on the no evil eyebrow. So that's 400 seniors cannot do the evil eyebrow. And 300 of the 400 can do the taco tongue, and that's about 75%. So if these two values were the same, then it wouldn't matter if someone could do evil eyebrow or couldn't do evil eyebrow, because they'd be able to do the taco tongue at the same percentage. So they would be independent. But no, because these percentages are different. All right, so number 7 says we want to fill in the table. We want to create data so that the events are independent. So let's take this top here, the 6A, that 80%. And let's try and make it so that whether or not they can do evil eyebrow, they can do taco tongue at 80% of the time. So this value here, we want 80% of this 200. So we can take 0.8 times the 200. And then when we multiply that, we'll get 80% of 200, which is 160. And then the leftover there is going to be how many more people can't do taco tongue to get up to 200. That looks like there needs to be 40 more people to get up to 200. And then if they can't do evil eyebrow, there's 400 people there. So we want to find 80% of that 400, which when we multiply that gives us about 320 with 80 left over to get up to that 400. And we can do a nice little check here. 160 plus 320, that gives us 480. 40 plus 80, 120. Looks like we did pretty good there. So now we want to figure out if it's in, we want to double check, make sure it's independent. All 3 of these should be the same. All 3 of these, A, B, and C here. We want the probability of A, the probability of A given B is true, and the probability of A given the complement of B is true. So we're going to find the probability of yes, taco tongue. And we already did that. We saw that it was 480 people out of 600. So we got 480 out of 600, and that gives us 0.8 or 80%. Yes, Taco Tongue, given the evil eyebrow, so we're just focused on this black section there, so that'll be the 160 out of 200, which when we divide gives us 0.8 or 80%. Then finally part C, yes, Taco Tongue, given no evil eyebrow, that's at 400 people there, which 320 out of 400 is 0.8 or 80%. So we should notice in number 6 is that all those probabilities are different, versus in part 8, all those probabilities are the same. So we can say probs in 6, all different, versus the probabilities in 8, all the same. So if two events are independent, then we will know that the probability of A is going to be the same whether we're told that B is true or if we know that the complement of B is true. And those vertical lines are given. That tells us conditional probability. So we're going to finish up with some notes on the top of page 11 here. We're going to start with conditional probability. And that is the probability of A given B. A given B. And one way to calculate that is to use the data like we did before, or we can find the probability of B, and we're going to have that divided by dividing probability of both. So for a quick example from before, if we had, let's go all the way up here. So if we were looking at probability of, let's say, this is our B here and this is our A. So the probability of this 200 B happening is 200. So that'd be 200 out of 600. You do not have to write this down. And we would divide by the probability of both of them happening, which would be that 180 out of 600. What would end up happening when we divide these is the 600s cancel each other out, and we're just left with that 180 out of 200, which is what we said right there, that 180 out of 200. So when we're looking at data, we're kind of taking a little shortcut because we're getting rid of that denominator real quick. So let's erase that. We do not need that. That was just a little quick example explaining how that formula works. There might be times where you're just given the percentage and you'll have to just plug in those percentages and divide them and get a new percentage or a decimal, either way. And then let's finish off with independent events. That'll be when knowing one event has occurred does not affect the probability of a second event occurring. I think occurred has 2 R's. Let's put the R there. And then we will have our little formula that we had up above. That probability that we defined right there, if events A and B are independent, then probability of A has the equal probability of A given B has the equal probability of A given the complement of B. I'll write that down real quick. Probability of A is probability of A given B is probability of A given the complement of B. So in class, you should be able to do the check for understanding down here, and then you should have a Math Excel as well. Good luck.